This is my final lab. I chose to do one similar to another lab in the spring in 2 dimensions, but I just used a different video. The main objective was to analyze and track a spring in motion. It has both x and y dimensions, and calculate the corresponding change in the potential energy of the spring. My main result was, by making the system include the spring, we know that the work done is equal to 0. From that, there must be a potential energy of the spring included in the energy principle calculations. This resulted in a delta U of the spring as negative 0.000726. These are the parameters that I used for my calculations. The L naught is 0.126 meters. The mass of the ball I estimated to be 25 kilograms. I used the same spring constant, assuming that he used the same spring in class that he used to make the video. And then the delta T, and we have the initial ball position. And you'll see when I go to the tracker video, I had to compensate for the orientation of the video, so I just rotated the axis. So you can see this is the positive y, this is negative y, negative x, positive x. So just as it were, had the video been flipped. So this is the tracker of when he did a demonstration in class. Oh. You can see the graphs forming, and we'll get to the graphs later, but it has 2 dimensions. It's moving both in the x and y. It goes up and down, side to side. So this is the computational equations that I used in order to calculate my delta U of the spring. We found, because we know work equals 0, we were able to use the energy principle and calculate the kinetic energy and the potential energy. And then we just had it output values, and we input, you can look at the model of the spring. The yellow ball represents the computational model, and the blue ball is the model of the data that we used. You can see that they have the same path, so we know that the spring is behaving just as we would expect it to. These are the graph of the x values. It's only part of it because there are too many to fit on the entire thing. But this first graph is just the displacement of x against the change in time. And then this graph down here overlays the experimental and computational, and you can see that they have the same amplitude and path. So we can say that the computational model is a good fit for what we saw happen in our actual video. I did the same for the y, and it's just in the y direction, y versus time, and then the comparison between computational and experimental y values. And then I graphed our change in spring potential over the amount of time that we had tracked the video, and we're able to get a U value from this experiment.